I'm going to be solving the 2007 AMC 10B problem 22. Let's read through the problem. A player chooses one of the numbers 1 through 4. After the choice has been made, two regular four-sided tetrahedral dice are rolled, with the sides of the dice numbered 1 through 4. If the number chosen appears on the bottom of exactly one die after it has been rolled, then the player wins $1. If the number chosen appears on the bottom of both of the dice, the player wins $2. If the number chosen does not appear on either of the dice, the player loses $1. What is the expected return to the player in dollars for exactly one roll of these dice? So on this problem, we're going to use expected value. So this is basically just the probability of an event occurring. So let's call that event P of E times the amount of money we earn. So we can say times $E. And so this is going to be our expected value. Probability of the event occurring times the net gain from that is going to be the expected gain for that event. And so in this we have three possible events. So let's break it down. We can have one dice be correct. We can have, actually let's just first do this case. So the case in which exactly one die has the number that you chose, but the other one doesn't. So the probability of this occurring is 1 over 4 times 3 over 4. And you're going to gain $1 from it. But then we also have to note that this can happen in two different ways, because it could be the first roll or it could be the second roll. So times 2. Now this is equal to 3 over 16 times 2, which is equal to 6 over 16. Our second scenario is with two dice. The probability of your number appearing both times. So the probability of it occurring the first time is 1 over 4, times the probability that it occurs the second time is also 1 over 4. Now, the question says that you win $2 from this. And we don't have to multiply by anything else, because if your number gets rolled both times, that can only happen in one arrangement. So now this is equal to 1 over 16 times 2, which is equal to 2 over 16. And in fact, I should write plus and plus, just so we know we're gaining that much money. So in this one, it's plus 6 over $16, and in this one, it's plus 2 over $16. Now, our third and final case is in which the number doesn't appear on the bottom of either dice, or of either roll. So this would be 0 dice. Now the probability of this occurring is 3 over 4, because your number can only happen one time out of 4, so 3 out of 4 times it won't occur, times 3 out of 4. And here you lose $1, so let's multiply by -1. Now this can happen in exactly one way, and because there's no arrangement in which your number gets chosen, so it's both times, or on both rolls your number doesn't get rolled. So this is equal to 9 over 16 times -1, which is equal to -9 over 16. So this results in you losing $9 over $16. Now the last part of this question is the easiest part. We just have to add up all these expected gains and expected losses. So the first case, it's going to be plus 6 over $16, plus 2 over $16, and finally minus 9 over $16. This gives us 8 over $16, minus 9 over $16. And so the final answer is minus 1 over $16. And that's B.